Hello, this is William from Visual Components. In this video, I'm going to show you how to make an advanced component creator that can make different types of parts and also make them parametric, for example, change their size and material. Before you get started, make sure you are using Visual Components Professional or Premium because you need access to the modeling tab here. We will also be using Python API, so if you're not comfortable with using Python, go ahead and look at some other tutorials on our Academy to get up to speed. To get started, we are going to make a very simple feeder, a type of component that can make components during the simulation. We'll create a new component, give it a new name. I'll call it feeder. I'll now give it a box or block feature and change its length to be 500, its width to 500, and its height to be 700. I'll now use the conveyor wizard, which you can see here, to quickly create a path or container for parts that are going to be created. For my frame mode, I'll create them along the top face of the box, so on this top face here, in the X direction. We don't need an input for the feeder, but we do need an output to flow the parts into, for example, a conveyor. And I will select this option here to automatically create a component creator behavior in the component for making those parts. Everything looks good, so I'll click Create Conveyor Behaviors. You can see the frames are here. Click Close. If I run the simulation, you don't see anything because we haven't defined what part that component creator will make during the simulation. So let's reset. Go to the component graph panel. And for our behaviors, you can see here's the path. It has an input and output port. It has a component creator. The output port is connected to the input of our path. And if we select a component creator, go to the properties panel here. Its part property is empty right now. So you could browse to a component file you want to use as a template or type in a VCID. Let's do that. I'll go to the Home tab. In my eCatalog panel, I will expand models by type. Scroll down. Go to Products and Containers. Let's make a box. We have a couple of different options, so let's make the VC box here. So I will right-click, view its metadata, and copy its VCID here. So select Copy, close it. In the component properties of our feeder, you can see that component creator behavior does have some options here. So we can define the part. I'll type in VCID, colon, use the Control and V key to paste in the VCID and press Enter. It loads the part and finds it. There's no errors, so if I run the simulation, there's the box. This is very similar to what we did in the first video for a component creator, so I expect you to kind of have some basic understanding of what I just did. We can tweak this or customize the feeder away, so instead of creating boxes at the beginning of our block, we can create at the middle. Let's reset, go to the modeling tab. We don't need path frame 1 anymore, so you could delete the frame, but select the path behavior and its properties, go to its path, expand it, and just remove path frame 1 from that path field. Run the simulation, and now the boxes are created here. As always, save your work, so I will save this component. You can add metadata if you want. We are creating a new VCID for the feeder itself. And you can save this component in your My Models folder. Okay, so by now you should have saved the component in your My Models folder. And now let's test the wizard. I'll go back to the Home tab. And under Models by Type, go to Conveyors New. And add a conveyor to the 3D world and use the PMP command to plug the conveyor into the feeder. The yellow arrow turns green, so that's a good active connection. Run the simulation, and the boxes flow from the feeder onto the conveyor. Yes. Let's stop the simulation and select the box. It doesn't really have any options to make it parametric, but we can try changing its material. But before we do that, let's create a different part. So we'll select our feeder. Notice we only have one option for a part. So to add more parts, we just need to add a different component creator and then use that in a script. I'll go to the Modeling tab, and the Behaviors drop-down menu here. Under Material Flow, click Component Creator. We now have a second component creator, which has a new part field. Let's go back to our Home tab, and on the eCatalog panel, go to the Products and Containers Smart Collection again. And let's do another search for a box. I don't know if any other ones are actually parametric. I know this one is here. There's the basic box. So Let's view its metadata. Copy its VCID. Close it out. In the component properties for our feeder, you can see we have a tab here for the component creator 2. So for its part field, let's type VCID : Control plus V key, press enter. It finds the box, run the simulation, but it's still creating that first box because that is what is flowing into our path behavior, that container that we have in our feeder. So to create the other type of box, we have to use a Python script to switch out the connection. And I'll show you how to do that now. In your modeling tab, go to behaviors, the ribbon, and then miscellaneous, add a Python script. If you are new to Python scripting, don't worry, it's not that much code. We're mostly just using the component data you can see here. We're getting the path object, the creators, and we're manipulating their ports. The one thing I forgot to do is to set the component creator, its interval and limit to 0. You could just set the limit to 0 and that will allow you to create the parts using script, but in this case we'll just do it for interval and limit. So that's the first one, and now the second one. So interval and limit to 0. If you run the simulation, you can see no part is being created, so we have to use our script to create the parts now. So I'll reset, and let's make our editor a bit wider. I'll make the text bigger for you, and I'll delete these lines of code for right now. First thing we want to do is get the component of our script, so I'll write comp equals get component. This method is being imported from VC script, and it returns the component that has this Python script behavior, so it's our feeder. We're working with the data you can see here in the component graph panel. With that, we want our path, so we'll use the component object to get a behavior by name. The path is called path, which you can see here. We then want our creator, the first one. So I'll use the component object to get a behavior by name. The name of that behavior you can see here is component creator. And then we want the second creator we added, so creator 2. Comp.get behavior. The name of the behavior is component creator underscore 2. Alright. And when our component creator makes a part, it has to flow or transfer that part into a container. So it can be a static container or a path. Right now, our first creator is flowing into our path, but we can switch out that connection where the creator 2 flows into the path. So we'll say the creator 2 output equals creator 2 dot. I need to actually use the Python API real quick, sorry. I'll go to the Help tab, go to Python API. Yes, even I have to look at the documentation. So it's a component creator. You can see it is a VC flow object as well. It inherits its properties. So let's go there now, VC flow. Scroll down. It has these common properties called connectors, but it should also have a method called getConnector, and yes, it does. So this allows you to return the connectors for transferring the parts in and out of different behaviors. So getConnector, you can give the integer or name of the connector. In our case, we'll just use the first one, so getConnector, an index of 0. We'll now do the same for the first creator, so creator 2 output equals creator. Oops, sorry, it should be creator 1. Creator 1 dot get connector 0. Now, what these two lines of code are doing is they're getting the output ports of both our component creators. We now want the input port of our path behavior. So for our path input, we'll use our path object, which we got here on line 4. The same method, getConnector 0. And now when we run our simulation, we'll use the onRun event. Let's have the creator 2 output connected to our path input port. And you're probably wondering, where is this connect method coming from? If we go to our API with a connector. It's a VC connector type object, and it has a method called connect. And the argument you have to pass is another connector object, which is what we're doing here. We get a port in our component creator. We're then connected with a port in our path. And then from there, let's create a part. So with the creator object, there's a method called create, and it should work using the template. Let's compile our code. We don't get any errors. Before we run the simulation, what do you expect to happen? Do you expect the first box we made to appear, or that second box that we selected? And it seems we got an error. I probably messed up some spelling here. Let's see, we have a global name creator 2, output is not defined. Alright, so let's reset. I'll keep this in the video in case you need to troubleshoot yourself. Sorry, I have a typo here. Okay, so good feedback. Go to line 12. Why is this name not showing up? Why is it not working? It's because we have, where we declared the variable on line 8 was a misspelling. So compile the code, run the simulation, and yes sir, there's that second box. So we're only creating one. Let's switch them out. So we'll have a delay here when the simulation is running of 5 seconds. And we'll connect the first component creator's output or port to our path. We actually can just copy this first line here on line 12. Just change the 2 to a 1. And then the second line here. Paste it there. Instead of creator 2, it'll be creator 1. Now if you compile your code, before you run the simulation, what do you think will happen? Will it create the same box twice or 2 different boxes? Hopefully you can see. We know it will create that second box that we selected, the brown one. And then we have a delay of 5 seconds, and then we're switching the connection between the creators and the path, and then we're using that first component creator to make that first box that has the VC logo on it. 5 seconds, there you go. So this is just a quick example of how you can make a feeder or a component creator that can create more than one part. You just add as many component creators as you need. Let's reset. And now let's get a bit crazy and make more than one part in a batch. So here we're just creating 2 and that's it, but let's use a while loop here. So while the simulation is running, while, you could just keep it simple and write while true, but if you want to be safe, you could get the application object for the software. So create a variable called app equals get application, and from here we can test if the simulation is running. So while app.simulation, which gives us a simulation object, is running, we'll perform this loop, and let's have a delay of 5 seconds between each instance of creating a part. Compile the code, there's no errors. Run the simulation. Both boxes will be created, and then a new batch will again be created. And simple enough. From here you could modify the component further. You could add more properties to the feeder to support different products based on what the user selects. You can switch out the parts however you need to. But I'm now going to show you how to modify the template component, or the part that's being used to make components during the simulation. So before we create that brown box, or when we create it, I'll get that part itself. So I'm just creating a new variable here that gets the part that's being created. From there, I can change some of its own properties. So I don't know too much about it yet, so what I'm going to do is stop the simulation when we create that first part. So app.simulation, I don't remember if it's auto halt. I think it's auto halt. Let me check the documentation real quick. And I am leaving this in the video because it is good practice to check the documentation, and in most cases you will have to go back and forth between the API reference when writing a script. So from our application object, we go to properties, scroll down to find simulation. Here it is. It returns a simulation object. And from that we should have a method. I think we can use the halt statement. The halt method. That looks a bit more safe. Let's see. Not sure. And yeah, it's actually probably easier just to start and stop the simulation. So I'm going to select this first box. I'll just double click it. Since I'm in the modeling tab mostly in that context, I can double click the object to select a component. It has a material. It has these properties called box length, width, and height. That's very nice. Let's use those. So in our script, we'll work with this data of that part. We don't need this line of code anymore for halting it. But for the part itself, let's set its box length. The box width, and the box height. Now, you can read the values directly from the component, just like this. That can return the value, but it's not a setter. It doesn't set the value. To do that, you have to get the actual property object. So we'll say box length equals part dot get property. What is the name of the property you want? It's box length. And then we'll set its value. So box length dot value. Right now it's 300. Let's change it to be 100. Very small box. And for box, let's just change the box height and the length. So we can copy this line of code here. And just change it from box length to box height. And the name of the property we want is box height. If you are a more advanced user with Python coding, you probably can refactor this and make the code a bit more nice, more simple. I'm just making it this way so it's easy to follow, hopefully. So for box height, we'll set the value to be 100 as well. And that's it. So if we compile our code, we don't get any errors, but the simulation's still running, so we have to reset to compile our script. And for these properties of our component, you can see I'm using the method called getProperty. Let's go back to our Python API. And in VC component, that's what we're working with. We'll go to methods. And you can see it has a method called getProperty and returns the property as an object. And from there, if you scroll down, you can set its value. So you can get or set the value. So that component has these three properties, and we're setting the length and height of it. If you run the simulation, what do you think will happen? Well, we probably should have a smaller box, right? And that's what we get, you can see. The next box is created, looks like that. But let's get a bit cray-cray. Let's reset and push the limit. Let's say at the start of our simulation we have a list of values for height and length. So we'll just call it, can't really think of a good word right now. Let's say dimensions. And it's a list of values. So we have 100, 200, and 500. And for our box length and width, we can get rid of these. And instead of setting the value directly, let's get it from our dimensions list. Dimensions, and we'll use the pop option here. This will just get a value from the list and remove it. Eventually we'll run out of items, so to keep it simple and easy to follow, I'll just use the first value in our dimensions list. And what this is doing is getting the first index or the first value in the list, which will be 100. So this is going to produce the same box we saw earlier, which you can see here. And we'll keep on using that same value. But what we can do is we can create a simple for loop. So for I in range, there's only 3 values, so let's just use 3 here. We'll do the same process that we had earlier, but this time we're going to get the value that's coming from our range function here, so 0, 1, 2. It will give us a different value for the dimensions of the box that we're making at the start of our process. So we'll change the 0 to an I to reference this variable, which will contain the value that's given by the range function. So compile. Before we run the simulation, what do you think will happen? We will have a box that has a length and height of 100. After the next loop, we'll have a box that is 200 in length and height, and then we'll have a box in 500 in length and height. So first one, so far so good. Yep, different box, different dimensions, I mean. And yeah, there you go. So that's just one way to edit the parts that are being created by your component creator. Let's now see how we can change the material. For that, we will use the application object, and at the start of our simulation, just call it red. We use the application object to find a material called red, and then we'll assign that to our part. So part.material equals red. So in your Visual Components Professional or Premium in the software, it has these libraries of materials, which you can reference by name. Red is a material, so you can just find it and then assign it to the box. And now you have a red box of different dimensions. Oh, but you're probably saying, William, I want a box with different colors. Okay, no problem. We'll do the exact same thing we did for the dimensions here. So let's do red, green, app.find material. We're just repeating the same steps before to practice our skills. So get the green material. Let's get a blue material. And then we'll just put it into a list of colors. So red, green, blue. And then for our part material, like we were doing with the length and height, we'll reference a list of values and get the index that's given by our for loop here from our range function. So the first box should be red, the next one should be green, the last one should be blue, and the process will repeat. Compile the code, and that is what we expect to happen. Red box, show me a green box. Come on, baby. Yeah, there we go. What about blue? Blue is good. Can we go back to red? Yes, we can. And it just goes over and over again. Before I end the video, I will show you an option to switch out which part is created based on a property in the component. To do that, let's select our feeder. So just double click it. At this point, you probably want to save your work. By now you should have saved the component. Let's go back to the modeling tab here, and we're going to add a component property that is a string or string of text, and we'll change its name to be product. We'll make it visible. We don't need to rebuild anything in the component, but we do want to make it editable, or you can read and write it. For its value, let's just create a list of values here. So using that tooltip, each line is an allowed value. So our product property can support a VC box or just a normal box. So 2 values. And if you click the product field here are those 2 choices. So by default, let's create the box. Close it out. And you can see it listed here now in the component graph panel. The current value is box. So instead of creating different ones, what we'll do is we'll create just a simple dictionary. And this is kind of leading into the next video that really gets into some advanced features of a component creator by reading in an Excel sheet or a CSV file. We'll say the part itself, or parts, is a dictionary. So we'll have key value pairs. So if the value is box, that refers to creator 2. And then comma here. If the value is, or sorry, if the key is VC box, that refers to the first creator, creator 1. And then at the start of our simulation, we're going to get the value of that product property of the component. So let's say product equals parts, and the key here will be the value of our product property of the component. So comp, and like I showed you earlier in the video, you can just read the value from a component property this way. You could get the property, which you see here, but this is just a quick, easy way to get the value that property has. So from here, this is actually giving us a creator, not a product. So we do want to make it simple enough to read. And maybe leave ourselves a note. So get the creator for the selected product. Then from here, we'll refactor our code a bit. We'll say the port is the creator.getConnector 0. We'll then connect that to our path input port. So path input .connect, but we can just use the creator itself, or port, sorry. So port.connect to the input of the path. So we don't need this line of code anymore. We don't need this line of code. We actually have to refactor it a bit. The name of the variable we're using now is just called creator. And from there, we could change the material, but we don't know if the part that we're making now has, these properties. It does have a material, but I'm not sure it will change anything. But let's just assume that if the part name is equal to box, then we'll do this. We'll change its material and its dimensions. And regardless, we'll have a 5-second delay before going to the next iteration in our loop. So we'll remove these last lines of code here. So we've already kind of refactored and changed up our code a bit. We'll get the application object, the component, the path, both of the component creator behaviors. We have their output ports, but technically we don't need these anymore, so I will delete them. We have the input port of our path here. We have a dictionary that references which creator to use based on the value of a property in a component, which we are getting here. We have a list of dimensions that we may want for our product, some materials as well. And when our simulation is running, we're going to create a part, make sure the creator that we're supposed to use is connected to our path, and that part will flow onto that path. And if the part has this name of box, we'll change some properties of it. So compile the code, check your script for errors. Doesn't have to be any. Right now the value of the property in the component of our feature called product is box. So what do you think will happen when I run this simulation? Will it create that box with the VC logo on it? Or will it create that box that we were using to change its color and its dimensions? It will be the latter. It will create that box that we made parametric. And there you go. So it's not going to create that second type of box. It'll just create this one box, but different colors, different sizes to it. But we're not done yet. Let's test our work. Let's select our component itself in the component graph panel. Go to its component properties, and for its default properties, there is that product property we added. Let's change it to be VC box. Run the simulation. What do you think will happen? It creates that same old box with the VC logo, doesn't change its material or its dimensions. Alright, good stuff. Now I do recommend you play around with this further. You could use different product names as well. With the component creators being shown in the component properties panel, often enough that is too much, so you actually can hide these if you want. For example, if a user is using the Home tab and they see this, they're like, which one do I use? You can go to your Modeling tab, and you can add an underscore hide underscore to the end of the behavior's name to hide its properties from the component level. I'll show you. Select the first component creator. You could double click its name here, or click, pause, and click to edit the name here, or go to its properties panel over here. So 2 underscores, hide in capital letters, followed by 2 underscores. Press enter. And if you select the feeder as a component, you can see that the first component creator, its properties are not being shown here. We can do the same for the second creator. Underscore hide in capital letters, underscore. Go back to the feeder, and you have simplified component properties. You just select which part you want to make, run the simulation, and there's the part. Switch out again to create that box based on some type of settings you have. Now, of course, using a script for making parametric boxes, different dimensions of the same part over and over again is a bit tedious. You probably want to have this defined in some type of batch or some distribution or Excel sheet or CSV file. I'll show you how to do that in the next video. But if you have any more questions about this video, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.